Is your job search stuck? Maybe you're not getting any interviews with employers. Or maybe you are, but no job offers. Or you may be new and not even know where to start. This is Charles Max Wood, and I'm releasing a new course and ebook on how to find a job as a software developer. The course walks you through the process of finding the types of companies you want to work for, getting their attention, and putting your best foot forward as the candidate they want. I've coached dozens of developers in looking for jobs and have been able to help several people find jobs within 2 weeks to 2 months. So whether you're new to development, can't find a great job that fits what you want, or looking for remote work from an area without a strong tech community, I can help. Go to getacoderjob.com and sign up today.
Welcome to Elixir Mix, your weekly Elixir podcast talking with members of the community. My name is Mark Ericksen. On our panel today, we have Josh Adams.
Ahoy.
And today we have a special guest, Pete Corey.
Hey,
Welcome.
everyone. Thank you.
So, Pete, can you just kind of tell people a little bit about yourself?
Yeah, sure. I'm a software developer, and I run a very small web development consultancy. I work for various clients doing various things using various languages. Most recently, it's been Node and React, but I'm trying to branch more into Elixir. So I do quite a bit of Elixir work in my free time, and I blog quite a bit about what I find and what I'm working on and various projects and discoveries.
So what path kind of brought you to Elixir?
I think, I've been doing Node quite a while, ever since I left kind of the corporate world. And Node definitely has its limitations in terms of like concurrent programming and building scalable systems and solutions. I found myself kind of not understanding concurrency at all. I would scale applications by just horizontally scaling without any regard for all the complications that actually causes. So all my applications would have all kinds of errors that I could never really figure out. I had no idea what was breaking. It was like there were, ghosts in my code or something. And I saw Elixir, I think it was Hacker News article about this language called Elixir. And I think that was, around the 1.0 era, something like that. I don't totally remember. But I started looking into it, and the obsession with correctness and concurrency and building these scalable solutions that actually work, don't have ghosts in their code, was kind of an eye-opening experience. So that was the start, and then I've been hooked ever since.
That's awesome.
Was there anything in particular that you were building in Node and sort of thought, man, concurrency would really make a lot of sense here, or having good primitives around concurrency?
Absolutely. I think the project I was working on at the time was a SMS bot that had to scale to like simultaneously text with, I think the highest number was 30,000 people at once. And my solution was to build a single server, like an instance of the server that did the thing, and then just spin up, 10 instances of that server. And that mostly worked, but there were very weird edge cases, race conditions that pop up. And discovering Elixir, I kind of had a light bulb moment of, this is how I should be building this thing. I shouldn't be just spinning up a simple node server and then spinning up 10 more of those, because that's going to be painful. I should have thought about failure modes and what needs to be scaled and what doesn't. And, if I scale this piece, this will break and things like that.
Yeah, I was building a cryptocurrency, or Bitcoin specifically, like multi-exchange in Ruby using the actor model, when I realized that maybe I was putting a whole, like, square peg in a round hole.
Yeah. And that's money. I didn't even deal with money. Just people's text messages.
I do think that one of the things that people experience, at least I experienced this coming to Elixir, was more of the focus on the kind of the mantra of let it fail or let it crash. Kind of forces you to think a little bit more about how do I recover from these failure modes. And that was it. Like, so you're kind of mentioning that, like with your Node situation where you had these complex race conditions and different things can crash, and then the difficulty is like, well, how do I get back to a good running state? And that's one of the things I've really enjoyed about Elixir is, like, rather than worrying about all the different ways it could crash and trying to stop it or halt it as fast as I can, I'm more concerned with how do I get back to a better running state, and using supervisors and everything to localize the damage and the crash to recover very quickly. But yeah, it's still just it's a mental shift, but it's one that I've actually enjoyed doing. You're putting a lot of the same mental effort in, but you're just saying, well, instead of worrying about this half where it's like, I got to prevent all the problems that could possibly happen, Instead of worrying so much about that, I'm focusing more on, okay, well, how do I just have it so it recovers smoothly? So what's that? Have you been able to build any larger kinds of projects with Elixir where you've been able to kind of bear any of that out?
So, I mean, I totally agree. Learning Elixir has completely flipped my mindset for building software. You know, back in the day, I would build the happy path, and then any errors that came about were, you know, bugs in the Jira board or Trello board, things I had to fix. But now I know that failure will happen. Failure always happens, right? So it's not a matter of building the happy path and pretending failure won't exist. It's figuring out how things fail and anticipating those failures ahead of time, which makes things a lot easier, right? In terms of bigger projects where that has kind of reared its head, I guess, probably the biggest project that uses this kind of like supervisor system and, you know, the need for concurrency was a Bitcoin project that I've been working on. I'm actually trying to re-implement a full node using Elixir, a Bitcoin full node. And awesome. Yeah, it is very cool. It's a big project though. I'm not done yet. So what a Bitcoin full node does basically is it connects to a large number of peers, which are just other Bitcoin nodes. And it talks to those peers, it exchanges blocks and transactions and all this kind of information. And then it does things with that information, right? But managing all those connections to all those peers, if I was just worried about the happy path, I would be prone to failure because all of these peers are using different versions, different protocols. They might be expecting different data. They might not even be Bitcoin full nodes. They might be some fork of Bitcoin. And Elixir really let me not worry about those failures as much. What I do is I spin up each connection to each peer as a process, and I treat that peer as if it were a peer that I would expect. And so I send it what I think it wants. And if it doesn't give me back what I think it should give me, I just kill that process and don't even worry about it. And that's totally a fine solution I found because there are so many peers that if I lose, 1, 2, a dozen, I'll instantly refill my pool. And so in that case, early failure and not worrying about failure really at all has really helped me with that project.
That's really cool. It sounds like it's a big project. And I know you've been blogging about this and kind of your journey along this process. Are you building this with any other people, or are you kind of doing this all by yourself, or what's this project like?
No, it's been a solo project so far. I kind of want to keep it that way. I started it as kind of a learning experiment. I was into Bitcoin before I started the project, and I was always interested in how it actually works. So I went ahead and I bought Mastering Bitcoin by Andreas Antonopoulos, and started reading through that. And he has quite a few examples on how to generate private keys and things like that. But all of his example code was using either like the Bitcoin library in C, C++, or he had a few Python examples. So I decided that it would be fun to re-implement those examples using Elixir. And from there, it just kind of took off, and I decided to, build my own full node.
That's impressive. So you've talked about online. I think it's great that you're sharing this process and like the learnings that you're going through, that you're just kind of blogging openly about it. I think that's awesome. And some of the things that you were showing in one of your recent articles was about, I just loved seeing that you were doing pattern matching with strings on the buffers that were received. And I just that's an awesome use case for Elixir, right? So what is like building this and like implementing this protocol and doing this in Elixir? What has that been like?
Oh man, it's been a learning experience. That piece you talked about, using pattern matching to match on these binary, inputs I receive from all these peers has gone through like at least 3 or 4 different, like completely different revisions. Like version 1 was just function head pattern matching, and that was fine for a little bit. But the code started to get crazy, out of control. So then I switched to kind of breaking things into little substructures and like having each substructure do its own little parse function that does uses with, which is where I learned about the with keyword to do destructuring. And then I switched to this like fully recursive binary pattern matching solution, which I am very happy with. And I think it's a very cool solution. So I think I would say that it's been a learning journey for sure. Everything I do teaches me something. which I feel like is part of the reason I'm so compelled to blog about it, because I feel like I'm learning all these cool new things as I go through this process that I can't help but share. It's just too cool.
Yeah, I feel that way, or I felt that way initially when I first ran into pattern matching on binaries or producing binaries. So when I was reading your serialization protocol, that was it's a fun little read. It's a really solid example of conciseness in Elixir.
Yeah, there's also a lot of weird little edge cases around like sub-byte pattern matching. So dealing with things that don't line up to full bytes. A lot of the standard library stuff deals with bytes and like concatenating strings. But if you want to deal with, here's 4 bits, here's 1 bit, you kind of have to dig a little deeper and figure out what's actually going on, which is pretty cool.
Yeah, one of the first things I did in Elixir was port a library from Ruby that was doing a TCP, actually UDP protocol on the Parrot AR drone, and then the TCP for the Sphero ball. And those were just like straight ports of Ruby code. And the generating of the actual messages was so ridiculously nicer to read on Elixir. It was that was really eye-opening for me, because I'd only done a little bit of binary munging with Ruby, and it's nowhere near as pleasant.
Yeah, I remember having to do like bitwise operators in C, trying to move bits around and pull bits out of integers and characters and stuff. Elixir is much nicer.
So I noticed from some of your articles that you're using Gen TCP. So can you talk a little bit about that? I don't think it's not talked about. I don't hear it talked about very often. So I'd love you to kind of share what that is and how you found it useful and why you chose it over some other options.
Yeah, sure. So one of my other goals with this project was to dig into the underlying Erlang utilities and standard libraries. I feel like a lot of people using Elixir don't really even know about them or explore them or try to use them at all, which I've come to realize is kind of a shame, because there is a ridiculous amount of really cool stuff in there. So Gen TCP is basically a process behavior. I don't know if that's the right word, but I'm going to use it. It's a process behavior that basically lets you establish and manage TCP connections through an OTP process. So you basically, well, you don't always have to use it through a process, but we can get to that later. You basically like give it a host you want to connect to and some options, and then it gives you back a process handle for communicating with that host. And then you can either send bytes to that host or receive bytes from that host. And it's really as simple as that. There are a few other options that let you deal with passing back and forth binary data. And there are a few options that instead of having to manually receive bytes from the host, it will just automatically send them to your current process as messages. And that's the route I took with my Bitcoin project. In terms of using other options, I know there are other options out there because people have told me I should have used them instead. I honestly didn't even look at them. I wanted to figure out Gen TCP because in my mind, it's there, it's available. I'm sure everything else is roughly based on it, so I might as well learn it first. So what do you guys think I should have used? Because everyone has an opinion.
I like just using Gen TCP. It's a very good thin layer over TCP.
Yeah, I haven't had too many problems with it.
I had exactly 0. That's why I'd be surprised I'd be interested to know why other people think you should have done something else.
Yeah, every problem I've had basically boiled down to just inexperience and not really knowing the best way, like the best patterns to use. So at first I was using an active connection, which I believe that's correct. It might be flipped. An active connection, which basically sends all incoming messages to me as process messages. And after a discussion on the Elixir Slack group, I realized that there was a better way. I switched it to a passive connection, and I manually request a certain number of bytes every so often. And that has worked out much better. But aside from that, I haven't had any issues at all. It's been very nice to work with.
When you say worked out better, what specifically was the problem before you did that?
Before I did that refactor, I had an active connection. So every time a peer would want to send me some data, it would send it to my server. My Gen TCP connection would basically take all the data they gave me and pass it to my current process as a message. The issue is that TCP is a streaming protocol, so it doesn't make any guarantees about whether or not the data it gives you is a full packet or even a single packet. It might contain multiple packets or half of a packet or 1.5 packets. And so it's up to you to kind of manage that stream of data. And so what I was doing was every time I received some data, I would append it to a buffer I kept in that process's state. And then I would look for header deliminators, these little magic bytes that basically say this is where a packet begins. And then right after that is the packet length. So I would look for the magic bytes and then the length, and then I would split out that number of bytes from my ongoing buffer. That was hard to explain, and that's because it's complicated. And the better solution is to simply manually request a certain number of bytes from my peer. So I'll say, give me, I think it was like 8 bytes, which is, no, it's not 8, it's more. Give me the full header, which is a fixed size. So give me those magic bytes, and then give me how long the following packet is going to be. So I request that, it gives it back to me. And then I say, okay, well, now give me that number of bytes. And so I get that, and I know that that's a full complete packet. And so switching to that active to passive mode really made things a lot easier for me.
Yeah, makes total sense.
And thank you, I forget who mentioned it, but it was someone on Elixir Slack that told me to make that change. So thank you. You should join the Slack. It's awesome.
I do think that's something, well, there's a couple points that you made there that were really great. One, yes, I think Elixir or Erlang has a lot of, has a rich history. It has a lot of built-in features and primitives that Elixir just builds on top of. And I do think it's beneficial to just familiarize ourselves with what are some of the things available in the Erlang Beam, the standard library that are just already there. And so I think it's great that you're using Gen TCP. I don't have a better alternative. I think it's awesome. Yes, I also think people should feel free to join the Elixir Slack channel. It's set up and it's available for anyone publicly. I'm in there. There are different channels for different like regional areas. We have one for Utah. So we have a lot of people there who meet there. And I love that. It's a great way to just kind of reach more people in the community that are local to you, or, I've been able to access people with specific questions about Ecto that I had that were very difficult, like especially in the earlier days of Elixir when there wasn't as much information available. So yeah, that's a great resource. Glad you plugged that one. So you also mentioned that you're using property testing. I think that's really cool. Property testing is one of those things that I want to spend more time digging into. I attended some of the talks at ElixirConf 2018, and where there were some talking about property testing. It's one of those things I haven't yet taken the time to dig into. So please give an introduction to what is property testing and how are you using it?
Yeah, so property testing is very cool, and it's also pretty new to me. The articles you read are probably like my first experiences with property testing. The basic idea, before we dive into that, unit testing is basically you write a function and then you write, a few tests that test what you think the expected and unexpected inputs, or I guess always expected, the expected inputs of that function should be. You test basic happy path, you test edge cases, and you look for failures. Property testing basically takes the process of writing those tests and finding those happy paths and those edge cases out of your hands, and it just automatically does it for you. So for example, if I was writing an add function that takes, arguments A and B and is supposed to add them together, I could write a property test that basically generates, any number, any size. I guess not any number. It generates two numbers, A and B, but they can be any numbers at all. 1, 2, 3,000, -700, things like that. It'll generate all these crazy tests to run, and it'll automatically run all of those against my function. And then I could assert that some property holds. So if I was doing add, what would I do? I might want to run property tests against various properties of the addition operator. So, it's associative, blah, 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 whatever. I don't totally remember all my math there. Or I could compare it against a version of add that I know is correct. So I could compare it against, the plus operator. That would be called an oracle test, which is just a fancy little word of comparing a result that you made to a result that you know is correct. And then it would go through all of those examples it comes up with, looking for any kind of failure. And if it finds one, the really cool piece is that it will try to simplify that failed example that it found into the simplest possible failure. So in our case, it might try to reduce those numbers into, more manageable numbers. If we were doing something on a list of values, it might try and shrink that list to be as small as possible, things like that. And in my experience, property testing has been ridiculously useful. Like I've found tests that I never would have, or I found errors and bugs that I never would have found a million years without property testing.
Could you speak to any of them? Like, because I imagine there's a lot going on in what you're doing with building a Bitcoin node or full node. So I'm just curious as to how you're using it. Are you using it to kind of create, I don't know, TCP packets, or are you using it to, like, what kind of experience have you had? Is there anything specific you can kind of share?
Do you run your own freelance business? Or maybe you're thinking about picking up some business on the side? Well, then you need FreshBooks. FreshBooks is the quickest and easiest way to get invoices out to your clients. It's easy to use. It works anywhere, available from any device, on the desktop, iPhone, iPad, Android, and all of your data is backed up and secure. And it makes it really easy to get organized and get paid. You'll be tracking time, logging expenses, and invoicing your clients in no time. You can also save time billing, freeing up several days per month to focus on the work that you love, and you get paid faster. FreshBooks customers are paid on average 5 days faster because there's a link on the invoice that says pay me now. And it's a great way to grow your business. Plus, FreshBooks is offering a 30-day trial. That's right, 30-day trial if you try them out. So go to gofreshbooks.com/devchat and enter devchat in the How Did You Hear About Us section. Once again, for a 30-day trial, go to gofreshbooks.com/devchat and enter devchat in the How Did You Hear About Us section.
Yeah, so I'm using various kinds of testing in my Bitcoin project right now. But the one place I am using property testing is testing the generation of, they call them BIP39 encodings and mnemonics. So basically, I take a binary and I run it through this process to base 56 encode it and then map that encoding onto a list of words. And that basically generates human readable Bitcoin private keys. So instead of having to remember, this massive string of hexadecimal digits, you just have to remember, a series of words. And I thought I had my base 56 implementation and BIP39 implementations ironed out and working perfectly, but I wrote a few property tests for them, and I realized that I did not have them working correctly. I was assuming that every piece of data passed into my functions would be, I believe it's byte aligned was the issue, but my property testing quickly found edge cases where it passed in arguments that weren't byte aligned and everything just failed catastrophically. I think this is interesting because this was kind of like an aside. Like I wasn't even trying to test this algorithm. I just wrote a property test. I think it was for something kind of unrelated, but this was involved. And the property test found this bug, which I literally never would have even considered. So I went back and I tightened up the constraints on that function, tweaked my property tests a little bit to generate more correct data, more expected data. And everything worked beautifully after that. So that was really an eye-opening experience. After that, I realized that I really need to incorporate property testing into my, my client work, my day-to-day programming, and basically everything that I do. It definitely blew my mind. That's
awesome. Property testing is still one of the things that's always on my list of things to do more than briefly play with.
Yeah, I always have to go back to the docs when I'm setting up a property test, the stream data docs. But once I get going, once I get in the swing of things, it falls together pretty easily. So I would definitely recommend checking it out. The hardest part by far is coming up with the properties that you want to test.
Right. That's actually the part that I look forward to, the more deep understanding of what I really want out of this thing.
Yeah, well, that's what you get, definitely. It's far more eye-opening than just unit testing. Unit testing, I feel like you're basically just, confirming what you already know. But when you have to sit down and think about these fundamental properties that your code should follow, it really helps you see things in a new light.
You have written a lot about your kind of process that you've been talking about with Bitcoin and your own learning. I'm just going to drop a link to those blog articles that you've tagged so people can check those out. I wanted to switch into another topic, but before we do that, is there anything else you wanted to say about the Bitcoin project, your articles about that? Anything you'd like to close with that section on?
Stay tuned. It's definitely still an ongoing project. It actually It connects to peers and it pulls blocks and transactions and stuff like that. But I haven't actually implemented the meat of it yet, which is to actually verify blocks. To do that, I'm going to have to implement the script language within Elixir, which is going to be a fun little project. So if that sounds like a thing you're interested in, definitely stay tuned. More is to come.
So where can people follow like some of this? Like, could you just, it's petecorey.com, right?
That's it. Yep. petecorey.com. That'll take you to my homepage, but you can go to petecorey.com/blog, and that'll take you to my most recent post, and you can explore from there. You can also sign up to my newsletter if you want.
I've written 2 little toy languages in Elixir, and it's surprisingly enjoyable to do so. So I think the script project will be fun.
Yeah, and I mean, going back to the Erlang standard libraries, aren't there utilities basically designed to lex and parse languages built into Erlang? Like, that blows my mind.
Leaks and Yak, I think.
Yeah, it's crazy.
Yeah.
Thankfully, I think this is just like a little simple stack-based language that has, bytes for operators. So I don't think I'll have to resort to leaks and lex, but the fact that they're there is very cool.
I didn't use them for my things either. It was always on my hey, I should look at this, but I never actually felt like I needed to.
Yeah.
All right. So we covered Bitcoin pretty thoroughly and property-based testing. What else ought we talk about?
Whatever you guys want. Basically, my other big project, I don't know if you're interested in, is using Elixir to programmatically generate some guitar chords and voicings and stuff like that. I don't know if that's something.
Yeah, I followed a little bit on your blog.
Cool. I talk about some pretty cool algorithms, so maybe we can dig into that if you're interested.
Yeah, generating music with Elixir is one of the fun little projects I went through. That's when I learned how PCM audio worked.
Oh, yeah. Man, I didn't go that deep.
It turns out it's really, really simple. All right, so what's the most interesting music-related thing? I know you did the distance between chords thing. What else is super interesting about that? About the music-related section of your blog, let's say.
Yeah, sure. Well, I'm working on this giant project I'm calling Chord because I don't have a good enough imagination to come up with a better name. That basically programmatically generates all these guitar chords. And it turns out that's a pretty complex problem. You mentioned I did a thing for voice leading between chords. So basically measuring the musical distance between 2 chords you play on the guitar. What I think is the coolest piece that I built is an algorithm. It's kind of a 2-part algorithm. It's an algorithm for generating all possible guitar fingerings or all possible fingerings for a guitar chord. So, I might want to fret this fret with my first finger and this one with my second, or I might want to do this with my second and this one my third, things like that. And then I can take that chord with a specific fingering and I can measure the distance between another chord with another fingering using a modified Levenstein distance. So I was pretty proud of that. I used a sieve for the first part of it. And then, like I said, I modified a Levenstein distance algorithm for the second part. I think that was pretty cool.
That is pretty cool. Have you seen Google WaveNet? That's a fairly recent-ish research paper that out of that comes their new text-to-speech generation.
I haven't. Is that related to the whole Google Labs, all those musical instrument and experiments they're doing?
I doubt it. So it's a convolutional neural network that they trained on. Well, they can train on various inputs. They do it on human language to identify to generate audio files that sort of will pass their test to generate the voice from text. But they did in the research paper. They also produced songs by seeding it with input set of songs. So it would make reasonable sounding songs by saying, yes, this is the thing that I would have expected to come next.
Yeah, that's very cool. Very cool. I've always wanted to get into that kind of thing, but I don't know. I don't have the AI chops, I guess.
That's what TensorFlow is supposed to be for.
Yeah, that's true. I've tried TensorFlow, though, and even just understanding the models kind of warps my brain a little bit. Maybe I should just sit down and spend a weekend.
So do you play guitar?
Oh, yeah. I play too much guitar. I remember in college, I sold my World of Warcraft account and I had just enough money to buy a guitar and an amp. And that was, 12 years ago, something like that.
Nice. Yeah. And so I see that you've also done some rendering of ASCII chord charts.
Yeah, that was fun.
Is that like for like frets for like I'm blanking on what it's called, but it's the fingering patterns, I guess. What's that called?
Fingerings. Yeah. That works.
But it's not the notes, right? It's not the like musical notes.
Right, exactly. It's basically like
tablature. That's what I was looking for.
Yeah, it's close to tabs. It's if you want to play this chord, where exactly on the fretboard do I put my fingers? That's kind of what it tells you. Mm-hmm. That was a fun project. I forgot about that one. This whole thing is a blur, you know? So basically I had this idea for generating these chords, and I wanted to get right to the meat of it, right? I wanted to make these algorithms that did these cool things that I had in my mind, but I didn't want to be burdened by, you know, all the cruft of making a web UI that renders these things that, you know, takes more time than the actual meat of the project. So I figured, instead of going that route, why don't I just keep everything in the terminal and render these ASCII chord charts? And so that turned out to be a pretty fun little Elixir project. I like doing these little standalone projects that kind of present a problem and then come up with a solution and maybe, you know, iterate on it a few times. I feel like that keeps my Elixir chops up, and hopefully it helps someone out there.
I do think that's a good way to learn, just because it is a small project that you can really iterate on and play with and then put away. So you don't feel like, oh, I have to now update that now that I've learned a better way. You can just start a new little project, right?
Yeah. And so like for the Bitcoin project I worked on, I actually did another standalone little thing that made a clone of the hex dump command line utility. So I wanted to see the bytes coming in and going out of my node. So I just, instead of like piping into hex dump and, you know, dumping the console output into my Elixir terminal, I just decided to rewrite hex dump and render it how I wanted. So that was the same kind of thing.
So I guess I did want to come back to one other question I had about Bitcoin that I hadn't thought about. Darn it, I was going to keep this all to music, this second half. Right. But so the question, I guess, was, I don't know what's involved with a full node, right? And I'm just curious as to how CPU intensive do some of these tasks have to become? Because I know, like, if you're validating blocks or if you're doing any of those kinds of like serious number crunching, is that part of the responsibility you have to implement there?
Yes. So Elixir might not have been the best language to build a full node in terms of the number crunching involved in validating blocks and mining for new blocks. But I still think it's a really good choice for the kind of inherent distributed nature of a full node. Speaking of CPU intense things, one of my early projects with my full node was generating BIP39 mnemonics. I mentioned that when we were talking about property testing. So basically what that is like a private key that maps to a string of words so you can remember it easier. I wrote a little utility that basically mines for these mnemonics, but it looks for mnemonics that follow the haiku pattern, 5 syllables, 7 syllables, 5 syllables. I thought that would be fun. And it turned out that was very CPU intensive. My computer would just scream at me while I was trying to find these mnemonics, but it was very cool. What's very cool, though, is that out of the box, you open up your observer and you see that all of your cores are fully utilized without having to worry about that at all. Like I didn't even think about, parallelizing anything or doing anything concurrently, but Elixir just knows how to do that, which is amazing.
That is super cool. So I was wondering, as you kind of continue in this path and you're dealing with things that are kind of CPU bound, have you considered, like, at some point you would want to bring in an external language just to maybe do some of those pieces? And if so, which language have you considered, or what path would you want to go?
Yeah, so I think it depends on the goals of the project, right? Like if I was trying to make a real full node that I view as a competitor to Bitcoin D, I would be worried about that kind of thing. In that case, yeah, I would pull in some other language. Knowing me, it's probably some language that I want to learn, like Rust or something. But if I wanted to keep it purely performant and purely compliant, I would probably just use Bitcoin D itself or the libraries that it uses. But I honestly think that the reason I'm doing this isn't so much to make a competitor, it's just to make myself understand. So I think that while Elixir isn't as suited to performant number crunching, I think that doing everything in Elixir is going to be more valuable to me and potentially the Elixir community than calling out to, something else that's better suited to it. As long as I'm upfront about that and say that, Elixir isn't the best language for everything. You should use it for everything, because obviously that's not true. But it's been nice to me, so I want to be nice to it.
Yeah, I think it's awesome that you're doing that. You mentioned Rust, and so I was just going to mention this project called Rustler, which is a library for making safe NIFs using Rust.
Oh, wow.
So it's a goal is to guarantee that you can't crash the beam writing one of these.
Very cool.
Anyway, really neat. I've heard good things, have not used it.
Do either of you play guitar or any instrument?
I technically play guitar. I was in a band in college and shortly after, but I haven't really played the guitar in like almost a decade. But I just gave I didn't give. I have loaned all my guitars to my son. But
there you go. Next generation.
So they at least get used now.
I plink. I have a guitar. I learned from a friend. And so I've never actually learned to read music. So I do like the tablature kind of thing and find a song that I'm interested in.
No guitarist can read music. It's fine.
Yeah, it's interesting because my kids are actually quite good at playing the piano and coming up with their own compositions and doing all this incredible stuff. And it's like, yeah, I can play some chords along with them, but that's about it. So I'm not that skilled, but it is fun. Very
cool. Well, hey, if you want some chord progressions, I know a project.
Yeah, and then hopefully the distance isn't so far between them that I can possibly reach them, right?
Well, that's configurable. That's the cool part.
So you can kind of make your own Guitar Hero, right? Kind of like game, like level of difficulty.
Yeah, so there's like a mode in your fingering distance that's like hard mode of life.
Yeah, exactly. Basically, everything it generates right now is hard mode, but I'm working on that. That's a 2.0 feature.
That's cool. Was there anything else you want to talk about before we close?
I think that's it. Thank you guys for having me on. I really appreciate being here.
All right. Well, yeah. And so I did want to mention that some of your articles have really been featured in the Elixir Weekly newsletter. And if people don't know about that, I did want to point that out as a resource. So we'll put a link to that, but it's elixirweekly.net. It's something I subscribe to as well. Just kind of hear about, it's a curated list of interesting articles and things that are going on. And so, yeah, it's really neat that you've been featured so many times. So that's awesome.
Yeah. Shout out to them. They always find awesome articles, mine not included. Definitely check that out.
All right. And if people would like to kind of learn more about you and what you're doing, where would you direct them to go?
So we mentioned my website and my blog, petecorey.com/blog if you want to go straight to the articles. I also tweet a lot. So my Twitter handle is Pete Corey, PETECOREY. And that's about it. I'm also on the Elixir Slack group, as I mentioned.
Are you Pete Corey on there?
I am. Yeah. Consistent.
Right. That's good. All right. And then let's move to picks.
For you, Loot Crate is offering an opportunity to save 10% on any new subscription at lootcrate.com. Just enter the promo code BRIDGE10 for 10% savings. Loot Crate is one of my favorite things. Every month I get a box in the mail, costs less than $20, and it comes with all kinds of goodies. I have stuff from, just looking at my shelf, Batman, Spider-Man, Ninja Turtles, Back to the Future, Lord of the Rings, Star Wars, and much, much more. So if you're a geek, a gamer, anything like that, and you want cool stuff to put around your office, cool t-shirts, comic books, etc., then definitely check out Loot Crate. To save 10% on your new subscription, go to lootcrate.com/Ruby. Again, that's lootcrate.com/Ruby to save 10% on any new subscription. Enter the promo code BRIDGE10 for 10% savings.
Josh, did you want to go first?
Yeah, I do. So, technical pick. I've been playing this week with some Kubernetes-related stuff, adding Prometheus and Grafana and Alert Manager to a cluster. I did it all one way, and then I came across a tool and rewrote everything. So the tool I came across is JSONet, which is a language for generating and manipulating JSON. So, for instance, you can import another JSON file or JSONet file and update one particular field or map a particular type inside of a particular field. And there are all these, and it's got a package manager, and there are libraries that you can use to generate for instance, libraries that generate Kubernetes resources. And so for that, there's a thing called KSonnet, which is based on JSonnet and is essentially like Rails new for your Kubernetes cluster for a particular application with very good, sensible defaults for the whole life cycle of the application in Kubernetes. And like there's a bunch of different ways you can go about doing this sort of thing. So having sort of a blessed path that is actually really awesome. Like the way that I do it now is what I always wanted to get to. And it turns out it was really easy to get there if you use this KSonnet thing. So if you mess with Kubernetes at all, you should look at KSonnet. And then by God, if you're implementing Grafana stuff, you should look at a library called Graphonet, which is a language for generating Grafana dashboards and other stuff in Grafana. And so like, whereas before I had all these files that I managed, now I have essentially 100 or so line file that spits out the 8,000 or so lines of YAML that produces this one subsection of this application that I'm doing. And it was just a giant mess to maintain without it. And now it's a little over 100 lines of code to deal with. So really cool. So
is JSON like almost like an XSLT for JSON?
Maybe a little bit. It doesn't feel like it though. It feels like you're just writing a language. So in one way that it's specifically not like XSLT is, I hate tag-based languages. So I don't like putting that baggage on it, but it's similar. But it has like a module system and plugins and stuff. So that's a way it's also, I guess, not entirely different, but it's good and pleasant. And it took very little time to get going with it and do pretty awesome stuff. And there's good support for it in VS Code.
Well, very cool. I'm currently maintaining a very large number of very large JSON files, and that sounds really useful. So thank you.
Yeah, and you can use it to generate JSON or YAML, or really anything else once you go from JSON to the thing, obviously.
So is that similar, like a replacement for Helm and charts for creating?
No, but you could build them in it.
Okay.
So no, but also you could in some ways replace it. So like I'm not using any Helm charts for my Prometheus and Grafana stuff. I am instead importing a library that produces the things and gives me sort of configuration hooks. So in some ways you could use it as a replacement for Helm. The ecosystem isn't quite as broad probably as Helm, but also it's not that hard to build your own. Like these are really just data that you're building. So it's not like it's super complex to build a library, I wouldn't imagine.
Nice. We'll have to drop some links to that in the show notes. And I'll go ahead next. What I was going to share is part of my development tool chain. And this is just a utility I use on my development machine all the time. It's called HSTR for history. It is an improved, like I use like a Linux machine. So it's Control R in a terminal to bring up a history of like recent commands and you can type. But it is a much nicer version than the typical bash history. And I will put a link to that in the show notes. It does work on Mac and Linux. And it gives just an awesome history, which you can filter as you type and, kind of delete things like, oh, I accidentally put a password in my history. Well, I can easily delete that. So that's one I really like, HSTR. And Pete, do you have something you can share?
Yeah, sure. So pick. Mine's not very technical, but last night I finished a book called The Sparrow, and I thought it was very good. If you guys are into sci-fi at all, definitely check it out.
Who's the author?
Mary Russell. The premise is pretty cool. It's basically like Earth intercepts some radio communications from a sentient species in Alpha Centauri, classic premise. But we actually we don't send, but they voluntarily go themselves. A missionary group of Jesuits actually goes and makes first contact. So it's kind of a weird mashup of religion and sci-fi and culture mashing. So I definitely recommend that. If you're into, I thought it was very similar to Left-Handed Darkness, if you're into, or if you recognize that book. So it'll be my pick.
I'm deeply into sci-fi, so I've purchased this now.
Cool. I hope you like it.
And Pete, do you do the reading or an audiobook, or how do you like to consume that?
I do ebooks. Yeah. So I read on my phone basically every time I have a minute. It's kind of a weird way to read. Like I read a paragraph at a time, but you go through pretty quick.
Hey, I do that too. So, and I also do audiobooks. So yeah, they're all good. All right. Well, thank you, Pete, for coming on. It's been a pleasure talking with you. And I'm glad you're able to share this information with us. And yeah.
Yeah. Thanks for having me. It's been a lot of fun. I enjoyed it.
All right. Well, thank you guys for listening, and we will see you next week when Elixir Mix.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.